Okay, now it's time for rational functions. So there's really only four types of graphs that you're gonna see. The first one is a linear, it looks like this. And the second one is a volcano. That's when whatever is down here is a perfect square with one x-intercept. Okay, if it's a normal quadratic, it becomes a driveway because your x-intercepts become the vertical asymptotes. I'll come to that. And when it's unfactorable, there are no x-intercepts. Well, there are no vertical asymptotes, so you only have your horizontal one, so it becomes like a speed bump. Now, first type of graph, let's talk about linears. Linears are in the form y equals a over x minus h plus k. You see how there's no b value? That's gonna be important. So what happens is, first of all, you have your normal what do you call it? Asymptotes. You have your horizontal asymptote, which is your k value. You have your vertical asymptote, which is your h value. The h value, the what do you call it? In a normal y equals 1 over x graph, the a value is 1, h value is 0, k value is 0, so our asymptotes are 0 and 0. And to find the points, well, there's no there's no horizontal stretch, there's no a value. So it's always going to be 1 away from your vertical asymptote, okay? And then since a is the vertical stretch, that's how much up or down you go. Now, since this is a positive, on the right side, we go up however many a value it is. So right one always, and then go up one. That's our first point. Then you go left one, and you go the other way. You go down. Okay? And then you just curve it towards the asymptotes. Curve it towards the asymptotes. That's all you need to do. Now you do have to find one more point because the like curriculum asks for 3 points. So whenever in any of the graphs, if you're trying to find one more point, just plug the number in. So y equals this is 2, 1 over 2. So this becomes 2 comma 1 over 2. Okay, 3 points always. And if this right here was a negative, right? You know how we go always go to a right and left one. Well, now instead of going up, we go down one on the right side and the other way on the left side. Oh, so now our thing looks like this. Okay, so the a value just tells us which side to how much up or down to go on the right side, and the other way on the left side. Now, with an actual question, the first thing you're trying to do, especially when you see a x in the numerator and a x in the denominator, is always divide. Whenever you see a x in the numerator, divide. That should be your first thing. Synthetic division, remember, whatever this is, you flip it, then you take the coefficients, plug them here. The first number just goes down, then you multiply. Okay, -1 times -2 becomes +2. -4 plus +2 is -2. This is your remainder, so that stays with the fraction. Okay, and this is your constant, so that comes outside. So now this is our final thing. So from this, we know our horizontal asymptote is going to be -2, which is our k value. Okay, y equals -2. And our vertical asymptote is going to be our h value. So it's going to be vertical. So x equals -1. H value is always negative, the other sign flipped. And now, remember, always one right from the, what do you call it, vertical one. And now it's a -2, so we go down 2. The a value is -2, so we go down 2. And on the left side, it's the opposite, so we now go up 2 on the left side. Okay, curve towards the asymptotes, and that's it. Now we need to find one more point, so I'll just take 1 because it's easy. So 1 plus 1 minus 2, it becomes negative 2 over 2 minus 2. So that becomes negative 1 minus 2, negative 3. So this point right here at x equals 1 is, sorry, 1 comma negative 3. Okay, so that's at 3 points. Now, with all of our questions, they're gonna ask these set of things, and they're actually pretty easy. They're easier than you think. Your non-permissible value is just what x cannot be, because if x is negative 1 here, this whole thing becomes undefined. So this cannot be 0, so x cannot be negative 1. That's our non-permissible value. Our non-permissible value is also our vertical asymptote. Okay, remember the h value. And our horizontal is the our k value, and our domain for linears is just, as you can see, domain is all the x except for that negative 1, and range is all the y except for that negative 2. Now the second thing is x-intercept and y-intercept. X-intercept, you make y0, y-intercept, you make x0, and then you just solve for the other thing. So in this case, we're solving for x, we get negative 2. This case, we're solving for y, we get negative 4, and we get those. End behavior tends to confuse people. End behavior just means what happens to x, these ends, the horizontal ends. So what happens is, as the value approaches negative 2, x approaches infinity from both sides. So absolute value of x approaches infinity as y goes to that asymptote. And now behavior near MPVs is the same thing, except now we're talking about the y values. What happens to the y when it reaches the NPVs? Okay, so as x approaches negative 1, the absolute value of y approaches infinity. So now the next type of graph is volcano graph. So first what you do is you always factor this, and it becomes x plus 2 whole squared. So what you do, first thing, you put in your asymptote. So this is a plus 0 here, so our plus 0. So our vertical asymptote is this, I mean horizontal asymptote, and our vertical asymptote is this, our h value, right? All our h values. So x cannot be our NPV, x cannot be negative 2, right? Because that's going to make it 0. So that's our one asymptote. And since there's only one vertical asymptote in a quadratic, we know it's going to look like a volcano. So with quadratics, you just pick 2 points on each side, plug them in and solve. So if we plug in negative 1 or negative 3, we get a y value of 1. So this is our point right here. Okay, this is our point. And now we have our main point. We just curve towards our x asymptotes. Okay, so always pick one point to the left, one point to the right to find the points. And then since we need one more point, let's just plug in 0. Okay, it becomes 1 over 4. 1 over 0 plus 2 squared, 1 over 4. And that's also our y-intercept. So that's another point that we can put down. So now again, our non-permissible value, looking at this, is x can be negative 2. Since our asymptote is at, what do you call it, y equals 0, we don't have any x-intercepts. Y-intercept we just found, 1 over 4. Vertical asymptote, same as NPV. Horizontal asymptote, k value 0. Domain is everything except negative 2. And range, now looking at our graph, there is nothing in the negative. So range is y is greater than 0 because it can be equal to. And end behavior, again, on the left and right, as y approaches 0, x goes to infinity. And for the NPVs, now since it's only going in one direction, we can say as x approaches negative 2, y approaches positive infinity. The second type of graph is the driveway. This is when you have a normal quadratic like this with two x intercepts. Two x intercepts means two NPVs. So our first NPV is positive 2, second is negative 2. So we put those lines in, and our k value is again 0. And now what we do is we take those 3 points again. First point is one to the left, one to the right, and then right down the middle. Okay. So when you plug those points in, when you plug in 3 and negative 3, you get 1 over 5. So our points are going to be very close to the intercept, to the x-axis right here, and then we curve towards asymptotes just like normal. And then the middle point we get negative 4, negative 1 over 4. So that's our point. So now again we curve towards the asymptotes. Okay, so that's why it looks like a driveway. Now again, non-permissible values, positive, negative 2, no x-intercept because our asymptote, y-intercept we just found, oh, negative. Vertical asymptote, same as NPV, horizontal asymptote, k value. Domain is XCR and x cannot be positive or negative 2, the NPVs. Now the range is a bit different because you see there's a bit of a gap here between 0 and the first point. Okay, so our range is going to be negative infinity all the way up to that negative 1/4. Wait, negative 1/4. And then it's going to be 0 all the way up to infinity. Okay, so you use union notation. And end behavior, same thing. For the ends, it's as y approaches 0, x tends to infinity. For NPVs, as x approaches to positive negative 2, well, these ends go up, these go down, so it's y approaches infinity. Now for the speed run graph, this is when this bottom thing is unfactorable. So you know there's only going to be one asymptote because there's no vertical NPVs. Okay. And so what you do, you take these 3 points, negative 1, 0, and 1. One to the right, one to the left, one in the middle again. Okay. With quadratics, always remember that. One to the right, one to the left. And if needed, one down the middle. So when we find these points, for these ones, we get 8 over 5, which is 1 and 3/5. So about here. And for the middle, we get 2. So now we just find this curve and then curve towards the asymptote. Okay. Curve towards the asymptote. That's why it looks like a speed bump. Now for the non-permissible value, again, there's none. There's also no x-intercepts because our horizontal asymptote is y equals 0. No vertical, no vertical asymptotes. Y-intercept we found 0, 2. Domain, since there's no restrictions on the x, it's XCR. And range, it's 0, not included, to 2. The highest point is 2. End behavior, there's no NPVs, so the only end behavior is as y approaches 0, x approaches infinity. Now some shortcuts to finding our horizontal asymptotes. You look at the highest power of the numerator and denominator. If they're the same, then you take the coefficients attached to it and divide it. So your horizontal asymptote, your y equals asymptote is going to be 3 over 6, which is 1 over 2. When the degree of the denominator is greater, now you look at your k value. Okay, so in this case, it's going to be 0 always because yeah. Now degree of the numerator is greater than denominator. Whenever it's this is greater, then there's no horizontal asymptote. Okay. So that leads us to our next section, point of discontinuity. With point of discontinuity, it's when you factor and when two things are dividing, one of the factors cancel out. Okay, so this factors out to be x minus 2, x minus 3 over x minus 2. Now the x minus 2's cancel out, and we're only left with y equals x minus 3, but x cannot be 2, right? In this case, there's no restriction, so we have to like respect our original restriction, and we have to include that. And that's why this is just a linear graph. This is just going to be a normal linear graph, except the only thing is at x equals 2, there's going to be a point of discontinuity, which just means there's going to be a little hole right there at negative 2. And that hole, that's how it's going to look like. Okay, so at x equals 2, there's a hole, and that's our point of discontinuity. Everything else stays the same. There's no NPVs, no asymptotes, x-intercept, y-intercept, domain range. The only thing that it can't be is their hole, which is at 2 and negative 1. You can find the y value by just plugging it in. Okay, and end behavior is just infinity, infinity, negative infinity, negative infinity. Okay, because it's a linear. Okay, so I made a little mistake. Then there is actually non-permissible value, which is x cannot be 2, right? X equals 2. I got confused because there's no horizontal asymptote. So there is no horizontal asymptote, but there's still a NPV. And so the behavior near the NPV is as x approaches the NPV, y approaches negative 1. Okay? Everything else stays. Now for solving, the last thing we're gonna do is solving. And solving is really easy. You're just trying to make all of these the same denominator. Okay, so what's the same denominator we can do? Well, it's 18x. We can all turn all of these into 18x. So we multiply this by 18, this by 6, this by 3, this by 2x. Get 144 plus 6x plus 3x plus 36 plus 3x minus 12 equals 16. Now we have the same denominator, so we can cancel all of them out. Once you cancel them out, it's just a normal algebra equation. Take all the numbers to one side, variables to the other side, simplify, and you get x equals 24. And that's it. That's all for rationals.